Today I'm going to be teaching you on how to evaluate the limits of exponential functions. So let's start. So what if we have a limit of, let's say we have a limit as it approaches x to 0 of the function 4 raised to the 3x minus 3 raised to the 4x over x. So how can we evaluate the limit of this thing? So what we're going to do is just use a technique called Hopital's rule. But first, we need to find out what is the derivative of an exponential function. So assume we have the derivative of a raised to the u. It is just a raised to the u times u prime multiplied by natural log of a. So how to do that? So let's do this. So what we're going to do is take the derivative of the numerator and the denominator. So here, I'm going just to take the derivative of this thing. And now what we're going to do is distribute the derivative. So we got this. It is going to be 4 raised to the 3x multiplied by 3 times derivative of x multiplied by natural log of 4 minus 3 raised to the 4x. We're just going to copy it, multiplied by the derivative of the exponent. So it's going to be 4 the derivative of x multiplied by natural log of 3. And the derivative of x is going to be 1. So what we got here is just 3 multiplied by 4 minus 3 raised to the 4x multiplied by 4. So we have an x here. I did forget to write it. Multiplied by natural log of 3. So now what we can do here is just plug in the 0 na. So we still have this. We still haven't plugged it in yet. So we're going to plug it this. It's going to be multiplied by 3 ln 4 minus 3 raised to 4 multiplied by 0 multiplied by 4 natural log of 3. So now this is going to be 4 raised to the 0 multiplied by 3 ln 4 minus 3 raised to the 0 multiplied by 4 ln 3. So now what we have here is going to be 3 multiplied by natural log of 4 minus 4 multiplied by natural log of 3. So that is going to be our final answer. So you can just type it in our calculator and get the approximate answer. Now let's move on to second problem. So what if we have the limit of x approaches 0 of the function e raised to the x minus e raised to the negative x all divided by x. So this is different from the other one because here we have e, base e, which is going to be the Euler's number. So the derivative of e raised to the u is going to be e raised to the u multiplied by u prime. So we're not going to put natural log of a because it will just be cancelled. I mean the natural log of e. Okay, so first step is going to be we're going to take the derivative of the numerator and the denominator. So what we will have is e raised to the x multiplied by 1 minus e raised to the negative x multiplied by negative 1, and the derivative of x is going to be 1 on the denominator, so we're not going to write it. So simplifying this further, we have this. So we have e raised to the x plus e raised to the negative x. So right now, we can just plug in the 0. So we will get this thing. So as we have that thing, we all know that anything that raised to the 0th power is going to be 1. So this is going to be also 1. And the answer is going to be 2. And that's basically it for this video. I hope you learned something, and goodbye.